Couple of years back, I created a video on this channel. It was God Tier Data Engineering Roadmap. Now, that time this channel was relatively very small, but that was one of the first videos to go viral because of the amount of details that I had provided. And in these couple of years, I did not create a repeat or another version of that video because I just thought that it was simply not required. But now we are entering 2025. There are lots of new tools and technologies that's eating up data engineering market share, and they are gaining a lot of popularity within the job description that we now see. AI is also one of them, so we are going to talk about that as well at the end of this video. And this is Josh. I'm a senior software engineer at DoorDash and an ex-data and AI engineer at Google. Today, I'm super excited to reveal the God Tier Data Engineering Roadmap for the year 2025. It's not only useful for computer science professionals who want to go into data engineering field, but it's also useful for somebody who is completely new in this area and wants to get started in data domain. Don't forget to leave a like and subscribe to the channel. Get comfy and let's journey into the world of data engineering together. First of all, what is data engineering? So data engineering is a practice where you design and build systems that can process, it can collect, and it can transform and analyze data at scale. It's basically a backbone of any data-driven decision system. And today we live in a world where the IoT sensors in your car or in your smart home or the screens that you're watching a YouTube video from, the amount of data has increased so much. So the need for data engineers obviously naturally increase. So why do I think that 2025 will be a pivotal year for data engineering? Well, we are at the cusp of technological advancements in AI, machine learning, and real-time processing. And without data engineers, none of it is possible. So let's talk about prerequisites first. So depending on your background, you may or may not know these topics. And if you don't, well, then this is the right opportunity to learn them before you learn anything else about data engineering. So we need to learn how object-oriented programming works, and specifically Python. I have always been biased towards Python. I'm going to admit it right away on this channel. And the reason I recommend Python for beginners is because its readability and understandability of Python is very high compared to Java or Scala or any other programming languages. And also it's great because it supports a lot of data engineering libraries. So there is a tutorial by After Hours Programming. So it starts with Python overview. It talks about Python operators, loops, classes. After going through this course, you will easily understand the basic syntax of Python. Next is learnpython.org. Go through the advanced tutorial. So when you click on, let's say, list comprehension, in that you will see different exercises, that code snippet on the left hand side, and when you click on run, you'll be able to see the output on the right hand side. A lot of times you have to learn object-oriented programming separately and Python separately. But if you are somebody who is completely new to computer science, the best place to get started would be learning about object-oriented programming using Python. So this course does exactly that. It's also free. OOP terminology, exploring object interface, what are different classes, how do you create your first class. It has so many different modules like inheritance and integrating with standard Python, best practice of class design. Now that we know Python, we know object-oriented programming, the next step would be to do some practice and go to LeetCode. Top interview 150 link, focusing on easy and medium problems. Do not even look at the hard ones because it's more for typical software engineering type of role, not for data engineer roles. Next is database management systems. I've given a link which is like a Geeks for Geeks tutorial about database management system. Now, if you see on the left hand side, these all are the things or the high level topics which are included in this course. I know that you might be feeling overwhelmed, but you don't have to go through all of this. You need to go through basics of DBMS, you need to go through entity relationship model, and relational model. One more thing that I would recommend is going through normalization as well. So that's it. Understanding these concepts about DBMS would take higher priority compared to anything else if you're short on time. The way to interact with your DBMS system is generally SQL. So learning SQL is very important for data engineers. The best place to get started would be from this W3 schools. You can see on the left hand side different topics about SQL. So let's say if I click on SQL count, there are different types of SQL counts that you can learn. You can click on try it yourself, and it will open a snippet where you can run SQL and finally see the output as well. Apart from SQL, one another way to interact with database management systems is through NoSQL. Now, I don't want you to spend a lot of time in understanding NoSQL just like you did SQL, but you need to understand the differences between them and understand when to use what. Operating system and Linux. So this is the last one of the prerequisites. So you can like see there are different sections: getting started, command line, and advanced text foo, packages, processes, permissions, everything. So if you click on command line, it will make you go through all the commands which are most often used in Linux. It's super important to understand them. Now we understood the prerequisites. We need to scale up. Usually data engineers deal with terabytes if not petabytes of data, and imagine doing something like this, even applying a simple join or aggregate of terabytes of data within your own local computer. Doesn't make sense, right? Probably it won't even fit into the memory. So to avoid that problem, you need to learn big data technologies. The one that is, I feel, the fundamental to learn right now at this day and age is Spark. You don't need to learn Hadoop or Hive because it's more or less outdated. Nobody uses it. So the best place to learn Spark is through this Udemy course, which is Taming Big Data with Apache Spark and Python. A couple of years back, I recommended the same one, and this time I'm doing the same because it's just that good. And the author has kept on updating that course. So if you look at the course right now, it was last updated on 2024 itself. You can look at the topic. So it starts with getting started with Apache Spark, and then Spark basics and RDD. RDD is basically the core data structure of how Spark handles any workload. It talks about data frames, data sets, how do you run Spark. It also talks about the advanced topics like machine learning with Spark ML and whatnot. But if you want to go with real-time processing, then I would recommend learning Kafka. Kafka is basically a distributed event processing platform. So if something happens, let's say user clicked on an XYZ button, and based on that event you want to process some data, you can do that easily with Kafka. Kafka can send that event data very quickly to your final data processing system. So it acts like a bridge between the interactions which happen live versus what happens in the backend in your data processing system. So to learn Kafka, this is the course that I recommend. It's called Introduction to Kafka. Let's see the course outline. So it starts with list of topics. What are Kafka producer? How you can write to a topic? What are Kafka consumers? These are basically the core concepts of understanding how Kafka works as a queue management system. Next is Apache Flink. So we talked about Spark, right, which is a great distributed way to run your data workload. But Flink always excels Spark when you look at real-time processing. So what Spark does is when it receives real-time data, it basically collates them into batches, and then once the batch is big enough, it processes that single batch. So it's not exactly real-time. It gives you a feeling that it's real-time, but it does have a little bit of lag. With Flink is specifically optimized for real-time. How do you do stream processing with Flink? What is Flink SQL? The beam, batch and stream processing with Flink, what is the runtime. Now this also has a topic that's how to use Kafka with Flink. So that's why it's very important to go in the same order that I'm giving you in this video. Otherwise, if you pick Flink first and then Kafka later, you'll be kind of really confused, and then you have to go back and understand Kafka first. Next is Apache Beam. So a lot of times there is a use case where some of your pipeline is on real time, some of your pipeline is on batch, and it does pretty much the same data processing. So Apache Beam is a framework that allows you to write same code for your real time and for your batch pipeline. On the Apache Beam's official website itself, you can see get started with Apache Beam. You can take a tour of the Beam. There are quick starts for Java, Python, Go. If you have learned Python, then obviously you should stick to Python quick start. And then there are example walkthroughs, some basic use cases and their implementation using Apache Beam. Okay, great. So now we understand big data technologies, batch and real time. The next thing is to understand an orchestration platform. So let's say you created a pipeline and it works well. You have one SQL script here, one SQL script here, and then they are being executed on a distributed system. So the performance is really good. But now you want to link them together. You want to execute this first, and then based on the completion, you want to execute second or third. If you want to set up an orchestration like this, then you need to learn orchestration platforms. One platform that has dominated the market in last decade and still continues to do so is Airflow. More importantly, if you understand orchestration concepts with Airflow, you can apply that knowledge on any other orchestration tools as well. Airflow has tutorials on their own website, so you can learn about fundamental concepts, how to work with task flow, how to build a running pipeline, and everything in detail. Next, there are some modern orchestration tools like Perfect and Daxter. If you want to learn more about them, I'm going to give a link. So this will take you through all the way from introduction to prerequisites asset dependencies, but I would say learning Dagster or Perfect is completely optional. Okay, so now you can write SQLs, you can put them on distributed environment, you can orchestrate them together, but where are you going to do that? You need to do them on cloud so that you don't have to own the servers, you don't have to pay large bills when your server is not being utilized. So learning cloud computing systems is super important for data engineers. I do not want to go on cloud wars. I don't want to say if AWS is better and Azure is better or Google Cloud is better. You know why? Because it does not matter. If you learn AWS, you can simply apply it to any job that has Google Cloud on their description. It's fine because most of the AWS, Google Cloud or Azure services have one-to-one mapping between them. That means they are essentially the same services, same concepts, just with different names. Us as data engineers, it does not matter which cloud platform do you learn. I can give an example as well. So when I started my journey, I did that on AWS. So for 3 years when I was at ZS, I only worked mostly on AWS. After some time, I moved to Google where everything was on Google Cloud. And now I've switched to DoorDash where again, everything is on AWS. Very easy to switch when you completely learn one of them. So if you're picking AWS, this is the course that I recommend you get started with, which is on Udemy, which is AWS Certified Solutions Architect Associate 2025. Now this course is specifically for a certification called Solutions Architect Associate. Important services for data engineer point of view that I would tell you to focus on more would be S3, EC2, EMR, Redshift, Kinesis, Lambda, SageMaker, and RDS. Coming to GCP, so GCP also has a similar certification. It's called Cloud Engineer Certification. So this will give you a really good idea about of all the different services at a high level on GCP, and more important services when it comes to Google Cloud is GCS, Compute Engine, BigQuery, Dataflow, PubSub, Cloud Functions, Dataproc, Vertex AI, and Cloud SQL. I know that it seems like it's a lot, but once you take these courses, it's going to be pretty straightforward, so don't worry about that. And similarly for Azure, I would recommend AZ900 Azure Fundamentals course, and you can learn that from this Pluralsight website. Now coming to data modeling and data warehouse. So there are two concepts to it. One is understanding a data model and how you can create a data warehouse from a concept level. And second thing is how you can use one of the services to physically create a data warehouse and interact with it. So to understand the first part, I would recommend going through this book, which is Kimball's Dimensional Data Modeling. This book is really helpful. Common problems like what different types of schemas are there in data modeling, how you can define entities and attributes, how you can connect them, what are slowly changing dimensions. It also has examples of different use cases and their example data models, which will be super important if you appear in an interview. Next thing is explore a modern data warehouse solution. There are multiple options you can either learn, Snowflake or Redshift or BigQuery, but the important thing is that you learn one of them. If you want to go with more cloud agnostic approach, I recommend starting with Snowflake. There is this course on Udemy, which is the complete masterclass. As you can see, it's not that expensive at all, and these are all the topics. It starts with introduction. It talks about Snowflake architecture, how does it all work in the backend, and it also has all the hands-on and high-level steps, whether you're loading structured, unstructured data, how you can load from different websites. You can also learn about concepts like Snowpipe, which is how you do real-time data ingestion within Snowflake. You can understand about zero copy cloning, data sharing, data sampling. These are Snowflake specific features which are extremely useful. Okay, so now when you learned cloud, you learned about data lake, which was, if you went with AWS, it was S3, or if you went with Google Cloud, it was, let's say, GCS. You also learned about data warehouse when you learned about Snowflake. One more thing that you need to learn about is a Lakehouse architecture. So data lake gives you more flexibility where you can store data however you want and you can store any type of data, but data warehouse is more structured and that allows you to update your data or update your tables very easily and perform ACID transactions as well. With the help of Lakehouse architecture, you can take advantage of both of them, and there are lot of technologies that enable us to do that, including Delta, Hoodie, and Iceberg. Out of all these three, my favorite is Iceberg. It can do pretty much what Delta Lake does, but it also has much more features. So you can go through this Starburst website. Starburst itself is a tool, so if you have time, go through that and see what it does. But if not, definitely go through this Iceberg course. It's really good. Now let's talk about transformation tools. When we meant data pipeline like 5 or 10 years from now, it usually meant ETL, which is extract, transform, and load. So you extract data, you transform, and then you load it somewhere else. But nowadays, a lot of data pipelines are based on the principles of ELT, which is extract, load, and transform. So there are a lot of advantages of this approach versus the older ETL approach. One of them being that, first of all, you're extracting and loading data, maybe in a capable system like Snowflake, and then you are doing transformation so that you can make use of highly distributed Snowflake environment instead of transforming it on your own. Now, one tool that allows data engineers to transform the data pipelines more effectively and interact with warehouse very easily is called DBT. Its full form is Data Build Tool. So check out this resource to learn more, which is like what exactly is DBT. And then you can go through it. You can see the modern data stack. You can see the data loaders. So once the data is loaded into the data warehouse, then DBT comes into play, and it can interact with raw and transform data, and it can connect with BI tools or any other data consumers as well. You don't need to expect in-depth DBT interview questions if you don't have that experience, so learning the basics is sufficient for now. Next is data lineage and cataloging. So data lineage makes sure that you understand where the data is coming from, where it's going, so that if something goes wrong, you can easily debug what went wrong. So there are a lot of tools which enable easy data lineage and data cataloging. Cataloging is about basically storing metadata. I have a specific video on my channel in which I talk about data lineage and catalog in depth, and I've also given a demo of a couple of tools which work really well for solving both of these use cases. So I'm going to link it right here if you want to take a look at it. There is this GitHub repository which is called Awesome Data Catalogs. So it has a comparison of all available data catalog right now in the market. It's a really good place so you can understand which use case is supported in what tool. Now let's talk about the more important data catalog tool that you can learn. There is an open source tool called Marquez. So it has a quick start guide. It talks about how you can set up Marquez in your local system or on your cloud platform and how you can make use of it. And then there are proprietary tools like Colibra. So if you want to learn that, which is not open source, you have to pay for it, but a lot of companies use it because it's really good. So you can go through this course which is about getting started with Colibra. Now, one of the most interesting topics is AI. Artificial intelligence is transforming data engineering, and I've said this in one of my videos that right now the importance of SQL in data engineering is obviously tremendous, right? Nobody can replace SQL, but 5 years down the line, I feel the importance of prompt engineering is going to be as important as SQL. So learning basics of AI is super important as a data engineer. I've created a video on this where I talk about 5 free AI courses that you can take right now, and I feel that every data engineer must take these courses, and it will make sure that you reach at a level where you can enable AI or at least implement some part of it within your data pipelines, so you can make your life very easier and you can completely optimize your pipelines. Instead of linking 5 different courses again, I'm just going to link that YouTube video and you can check it out and see the 5 courses within that video. Now, last section is infrastructure as a code and DevOps practices. Now, I know you might say that, hey, I'm not a DevOps engineer, I'm a data engineer, why do I need to learn all this? But as a data engineer, you do deal with infrastructure a lot, and a lot of times in a smaller company, the role of data engineer or infrastructure engineer or DevOps kind of gets mixed up. So this entire section I would say is optional, but learning it can be really helpful. I would recommend learning concepts like infrastructure as a code. So Terraform is used a lot for that. So learning Terraform is really important. Let's say I can click on AWS tutorial and you can see what is infrastructure as a code. You can see how you can install infrastructure, build or change infrastructure easily on AWS. So next is containerization. You ever ran into a problem where something was working fine on your laptop, but then it is not working well on somebody else's laptop, whether you created a code or whether you packaged some dependency? This is a very common problem in data engineering or in the world of software engineering itself. So Docker helps you avoid that problem. It kind of packages your applications together so it works well on any given system, no matter what the operating system is in the backend. You can click on this Docker Get Started guide. It talks about how can you get Docker, what is Docker. It talks about introductory Docker concepts and workshops as well, where you can do a lot of hands-on. So Docker was used a lot, but now there is another containerization that happens on top of Docker, which is called Kubernetes. Kubernetes is used in large-scale application or data pipelines a lot, and it was invented by Google. So there is a really interesting blog that Google Cloud has published about Kubernetes. It's basically a comic about what was the problem with Docker and how did Kubernetes solve it. And it's very interesting because it has like a story so you don't really get bored understanding the technical concepts, and it covers everything that you need to know about Kubernetes. CI/CD pipelines, again, crucial part of any software engineering role, including data engineering. It's about learning tools like Jenkins, GitLab, CI/CD. So you can learn about Jenkins through here. And the last is monitoring and logging. Basically, you can create a visualization about what is going wrong with your pipeline, what are different metrics that you need to capture using Prometheus and Grafana, so you continuously monitor your pipeline in the production. I recommend going through this Medium blog to get a high level understanding. It's okay. So that's it. Once you're at this stage, you know everything there is to know about data engineering. You're good to even give interviews at this point, but I would recommend before you do that, just go and build your own project. So it can be a batch processing or a real-time processing. You can think about any innovative solution that you can solve with data, and you can create a data pipeline on cloud. There is nothing that can substitute the knowledge that you get from your hands-on experience. Wow, that was a lot to cover. But remember that being a God tier data engineer is not something that happens overnight. So you can assess where you are, you can create a learning plan, use this roadmap. But I hope that it is useful, and do not forget to leave a like and subscribe to the channel. If you have any questions or anything, feel free to drop it in the comment and let's discuss it down below. Thank you so much for watching. See you next time.